Breaking news. A peculiar celestial object has just been identified hurtling through our solar system. An object so unusual that astronomers across the world are quietly calling it the anomaly. Officially, it carries the designation C/2025 V1 Borisov, named after its discoverer, Gennady Borisov, the same Crimean astronomer who stunned the scientific community years ago with the discovery of the second confirmed interstellar object, 2I/Borisov. But this time, what he found is even stranger. The object appeared without warning, emerging silently in the region between the interstellar body 3I/Atlas and Earth. It doesn't behave like a comet, nor does it shine like an asteroid. At first, telescopes caught only a faint haze, a diffuse sphere of light with no visible tail. Yet, according to Borisov's calculations, the object lies closer to the Sun than Atlas itself, which makes its lack of a tail scientifically perplexing. When ice and dust come near the Sun, they usually vaporize, forming a bright trail that stretches across millions of miles. But C/2025 V1, Borisov remains eerily calm, glowing faintly, defying every model we've used to predict cometary behavior. The initial photographs came from small observatories in Europe and Asia, showing what seemed like a dim, tailless orb. Some analysts dismissed it as a camera artifact. Others thought it was merely a fragment of a dying comet. But when the Crimean Observatory released a series of stacked, long-exposure images, the truth became undeniable. This was a new celestial body, moving fast, unpredictable, and most importantly, behaving unlike anything recorded in the past century. Now imagine looking up at a digital map of the solar system, three objects, 3I/Atlas, C/2025 K1 Atlas, and now C/2025 V1 Borisov, move in strange synchronized arcs. When viewed from Earth, their paths converge in an almost geometric precision. As though orchestrated by an invisible hand, astronomers note that this apparent alignment will reach its most perfect configuration on November 8th, just 2 days from now. To the naked eye, K1 Atlas glows softly in the constellation of Leo, its golden tail shimmering like liquid sunlight. 3I Atlas drifts within Virgo, cold, blue, motionless, while Borisov, faint and ghostly, passes between them. If you could stand on a mountain ridge and gaze east before dawn, you might catch a glimpse of this triangle of light, drawn across the morning sky like a cosmic symbol waiting to be deciphered. Michio Kaku's voice echoes calmly through the narration, as if translating the rhythm of the cosmos into words. 3 visitors, one from Leo, one from Virgo, and one traveling between them, all converging. What does it mean? Is it chance? Or is it a whisper from the universe itself? The data suggests the alignment isn't merely optical. According to simulations from SkyLive and Stellarium, the 3 bodies will form an almost perfect line with Earth and the Sun between November 6th and November 8th. Scientists call this configuration an axis of light, a rare but natural phenomenon. However, the timing raises questions. This exact period coincides with an unprecedented wave of solar activity. Massive sunspots erupting on the Sun's far side, spewing flares into space with explosive energy unseen since the solar cycle 24 maximum. For months, astronomers have monitored these solar storms. Yet something changed in late October. The flares appeared to aim directly toward the region of space occupied by 3I/Atlas. High-energy bursts of plasma, billions of tons of charged particles, were hurled in that direction, as though the Sun itself were responding to something. Then came a new variable. A small object catalogued as A6/Lemon entered proximity to the same region. And when researchers overlaid the solar alignment data, they found something astonishing. On November 5th, the Earth, the Sun, and a 6/Lemon formed a straight line, a colossal axis of energy stretching across the solar plane. At the same moment, the largest active sunspot cluster rotated directly toward this line, releasing flare after flare. Coincidence or resonance? The question lingers in every observatory meeting, in every encrypted scientist-to-scientist email chain. And now, Borisov's discovery, this silent tailless traveler, has entered the same corridor of alignment. Its projected perihelion, the moment it comes closest to the Sun, will occur on November 16th. If models are correct, Borisov will rise above the ecliptic plane, passing through the very axis connecting Earth and 3I/Atlas. To some, it's just orbital mechanics. To others, it's geometry written in starlight. Kaku continues. When three interstellar visitors converge so closely, when they align with our world and the Sun itself, astronomy demands an explanation, but science also teaches humility. The universe doesn't reveal its secrets all at once. China has released new images of 3I/Atlas, captured by the Tianwen-1 probe orbiting Mars. The photos are grainy, almost disappointing, just a dim blur moving across a dark frame. Yet their confirmation of the object's position and brightness is vital. For months, only faint optical data existed, and now at least one national agency has provided official validation. NASA and ESA are expected to release their data sets soon, but insiders whisper that the U.S. high-resolution images, particularly those from the Mars Reconnaissance Orbiter, remain under review. Meanwhile, amateur astronomers everywhere are watching. Forums on space weather and Reddit buzz with nightly updates, coordinates, and pixel-zoomed analyses. Some claim to detect faint motion near Virgo. Others argue it's merely digital noise. But one fact remains unshaken. Borisov's brightness curve doesn't behave like a normal comet. It doesn't fluctuate with solar wind pressure. It doesn't respond to radiation bursts. It just moves. And yet something strange happens on November 3rd, the date of its discovery. A geomagnetic storm of class G3 strikes Earth, disrupting communication satellites and briefly painting auroras as far south as Colorado and France. Statistically, there's no reason to believe Borisov has any influence on solar dynamics, but the timing, overlapping with a rare triple alignment, sends speculation spiraling through both scientific and public circles. Social media dubs it the silent comet. Others call it the Eye of Virgo. Kaku, with his calm authority, reframes the chaos into curiosity. Perhaps the universe is testing our curiosity, reminding us that the unknown isn't meant to be feared, but to be explored. Each discovery, no matter how small, reshapes how we see ourselves in the grand design of space. At this point in the broadcast, the camera cuts to a rotating 3D model of the solar system. Blue arcs represent the orbits of the three comets. A glowing yellow dot shows the Sun at the center. Earth appears small, fragile, suspended amid the dance of giants. As the animation speeds up, the orbits twist, cross, and align into an almost straight beam. Earth, Borisov, and 3I/Atlas in one line, like three pearls on an invisible thread of gravity and light. The narrator lowers his voice. If this alignment holds through perihelion, we may witness something humanity has never seen before. A cosmic mirror, a resonance between worlds, a pulse from beyond the solar boundary. The screen fades to black. The only words that remain, C/2025 V1 Borisov, November 16th, the day of alignment. The silence that follows is deliberate, not dramatic, but contemplative. A pause before the next revelation. A space for the mind to wander into the unknown, and for the story to continue as dawn breaks over the northern hemisphere. Telescopes across Europe, China, and the Americas turn toward Virgo. The world's observatories have entered what astronomers call the window of alignment. Three interstellar objects, 3I/Atlas, C/2025 V1 Borisov, and C/2025 K1 Atlas, are now positioned in an almost perfect geometric formation with the Sun and Earth. On the digital sky maps, they trace a radiant axis that seems to pierce through the constellations of Virgo and Leo. glowing faintly in the early hours of November 8th. The broadcast continues. Michio Kaku's voice fills the silence. Something extraordinary is unfolding in our cosmic neighborhood. For the first time in recorded history, we are witnessing three distinct visitors, each following trajectories that defy conventional understanding, moving in a synchronized celestial ballet, and yet none of our models fully explain why. The camera zooms into a 3D solar map, highlighting the motion of Borisov. Its orbit rises steeply above the ecliptic plane, a path more fitting for an interstellar drifter than a native comet. At perihelion, it will come perilously close to the Sun, closer than Mercury's orbit, before swinging back into the outer system. But what unsettles scientists most isn't the trajectory, it's the silence. No outgassing, no tail, no glow of sublimating ice. Images released by the International Astronomical Union show 10 verified observations of Borisov over the past week. 8 confirm the object's diffuse, tailless structure. 2 report a faint filament just 70 arcseconds long, barely visible, inconsistent, as though a ghost of vapor flickered and died. The data conflicts, the readings blur, but the conclusion stands. C/2025 V1 Borisov behaves like nothing we've seen before. Meanwhile, the solar surface roars. A series of X-class flares erupts from active region AR3216, launching coronal mass ejections that ripple across the heliosphere. The bursts are directed toward the exact quadrant of space where 3I/Atlas resides. As one flare after another lights up the Sun's limb, the alignment of Earth, the Sun, and Atlas forms what physicists call a resonant corridor, a region of overlapping magnetic fields that can amplify solar radiation coincidence, perhaps. But then the readings spike again. Space Weather Center reports a G3 geomagnetic storm impacting Earth's magnetosphere. Radio frequencies fluctuate. Auroras ignite as far south as Texas and Greece. Across the internet, skywatchers flood social media with green curtains and pink spirals draping the heavens. Amid the beauty, a question lingers in every caption. Is this connected to the alignment? Kaku's narration turns thoughtful, the tone that bridges scientific precision with cosmic wonder. Every so often, the universe orchestrates moments that feel deliberate, like notes in a grand symphony of physics and mystery. Whether coincidence or cosmic design, these alignments remind us that we're part of something far larger than ourselves. As he speaks, the screen transitions to new footage, images captured by China's Tianwen-1 probe orbiting Mars. The grainy frames reveal a pale glimmer behind a dark field, believed to be the nucleus of 3I/Atlas. Though low resolution, the confirmation is monumental. For the first time, humanity has recorded direct interplanetary imagery of an interstellar object from another planet's orbit, but excitement turns to frustration. NASA's Mars Reconnaissance Orbiter, equipped with a high-rise camera, is rumored to have far clearer photographs, yet those images remain unreleased, caught in bureaucratic limbo amid a temporary government shutdown. Politicians debate, scientists wait, and the public speculates wildly. Has NASA seen something it cannot yet explain? Kaku continues, his voice calm but edged with curiosity. When data becomes restricted, imagination fills the gap. But imagination is where discovery begins. Perhaps these objects, silent and indifferent, are not anomalies at all, but teachers. On the screen, data scrolls rapidly. Orbital parameters, solar wind velocity, magnetic flux measurements. Each data set pulses like a heartbeat. The camera pans to a digital simulation showing Earth, the Sun, and Borisov aligned in a near-perfect straight line. A fine beam of light stretches through space, a symbolic cosmic axis. For a moment, silence returns. Then, a faint tremor, solar interference distorting communications, crackles through the broadcast feed. The narrator steadies his voice. At this very hour, our planet sits within a corridor of solar resonance. Gigantic sunspots on the far side of the Sun are releasing radiation directly along this path. The timing, the geometry, it's uncanny. In scientific forums, hypotheses multiply. Some argue that the alignment's magnetic resonance could trigger chain reactions in the Sun's corona, increasing flare frequency. Others dismiss it as numerological coincidence. Still, the evidence grows, flare after flare, recorded with time-stamped precision, matching the predicted alignment. The narrative tightens. Kaku explains with clarity. Every orbit is a story written in mathematics. But what happens when those stories intersect? Could gravity, magnetism, and light synchronize in ways we don't yet comprehend? Or is it we who are reading patterns into the void? The broadcast shifts to a ground-based observatory in Spain. A researcher adjusts the telescope, the reflection of the sun burning faintly in his visor. Behind him, screens display images of 3I/Atlas, unchanged, intact, resilient. Despite weeks of bombardment by solar radiation, it remains stable, showing no signs of disintegration. One of the scientists speaks over the transmission. This isn't normal. Comets that close to the sun should shed material, change trajectory slightly, but Atlas hasn't moved. It's as if it's resisting the solar wind. The statement reverberates. The data confirms it. 3I/Atlas's gravitational acceleration is significantly lower than projected, suggesting an unusual density, perhaps metallic, perhaps unknown. Kaku's narration flows over the image like a reflection, an object that defies vaporization, a comet that refuses to obey the sun. What is it made of? Rock, metal, or something we've never encountered before? As the sequence unfolds, graphics visualize the triad of celestial visitors. One Atlas, with its golden tail, glows like an ember. Borisov drifts quietly above the ecliptic, a ghost, and 3I/Atlas stands motionless, reflecting sunlight with stoic brilliance. The camera pulls back, revealing their synchronized geometry, an invisible pattern carved into the void. A whisper of music fades in, soft, slow, cinematic. The voice resumes, 3 bodies, 1 purpose, or 3 questions orbiting the same mystery. Every observation seems to lead to a greater silence. Solar monitors flash red again, another flare stronger than the last. Analysts trace its path and gasp. The emission vector aligns perfectly with the corridor linking Earth and Borisov space agencies, confirm heightened particle density approaching our magnetic field. Communications may falter. Airliners reroute. Power grids brace. Then another anomaly emerges. Amateur astronomers in Chile report a flicker of light where Borisov should be invisible. A small reflective pulse, once, twice, gone. The observation is unverified, but enough to reignite the conversation. Could Borisov be more than rock and ice? Could it contain metallic compounds? Or worse, something artificial? Kaku steadies the speculation with measured calm. The universe is a storyteller, and we are its curious listeners. But sometimes the story reads us instead. Perhaps Borisov's silence isn't absence. It's information written in a language of physics we have yet to learn. The screen fades into the blackness of space, stars glimmering faintly, the faint outline of Earth's blue curve below. Whatever the explanation, Kaku concludes, this alignment, this brief luminous harmony between 3 wanderers and our sun, reminds us of our smallness and our privilege to witness it. The cosmos doesn't need our attention, but perhaps for a fleeting moment it allows us to see its design. The closing frame dissolves into text. November 8th, the axis holds. The hum of solar wind echoes softly in the background, as if the universe itself were breathing. The story pauses, but the mystery deepens. November 16th, the day of alignment. The sun rises over a world both restless and awed. Across observatories and research centers, all eyes fix upon the space between Virgo and Leo, the invisible bridge where 3 interstellar wanderers now form a single axis with Earth. The air feels heavy, almost electric. Radio instruments hum, satellites record, and in every laboratory, the same pulse is heard, a faint rhythmic signal echoing through the solar wind. Michio Kaku's voice opens softly, carrying a tone both scientific and reverent. This is the moment. C/2025 V1, Borisov has reached its perihelion, its closest point to the Sun. Its orbit places it almost directly above the ecliptic plane, aligning perfectly with 3I/Atlas and our world. For the first time in human history, 3 interstellar visitors cross the same corridor of light. The visual sequence shows Borisov gliding past the Sun, its surface faintly illuminated, still tailless, still calm. Solar flares erupt in slow motion behind it, giant arcs of plasma curling like fire serpents across the solar crown. Yet Borisov does not waver. The data streaming in from the European Space Agency confirms what few dared to expect. No sublimation, no dust trail, no deviation. The narrator continues, his tone deepening with each phrase. In the face of the Sun's fury, it remains unmoved. It absorbs, reflects, endures. Whatever Borisov is made of, it is not ordinary. Perhaps it carries the strength of an ancient material, perhaps the silence of a message. In Madrid, a small research team compares magnetometer readings from multiple stations. The same anomaly appears everywhere, a repeating modulation, faint but coherent, oscillating in perfect rhythm with the solar wind, yet slightly off by one harmonic. It's not a radio signal, not interference, just a whisper of patterned energy, emanating from the corridor where Borisov now travels. At the same time, the Hubble Space Telescope captures new imagery, a glint, a flash of reflected sunlight from the object's surface. Some call it coincidence, others communication. The sequence is too precise, too timed. 3 flashes, a pause, 3 again. Astronomers exchange nervous smiles across control rooms. It might mean nothing, it might mean everything. Kaku's narration steadies the rush of speculation. We must remember, the universe doesn't speak in our language. It speaks in gravity, magnetism, light, and perhaps in silence. The footage shifts to a panoramic view of the night sky, filmed from an observatory in Chile. There, faintly visible near dawn, 3I/Atlas and Borisov glimmer like twin embers separated by an ocean of darkness. The golden tail of K1 Atlas stretches beyond Leo, drawing the eye into the horizon. Together, the 3 points of light form a perfect triangle, a configuration that will not repeat for thousands of years. Solar activity reaches its peak. Another coronal mass ejection bursts from the Sun, sending a wave of radiation across the system. Instruments on Earth record the event as the most powerful solar flare of the decade. Yet again, the trajectory points directly along the alignment axis, and as the flare passes the region of Borisov, the object's brightness surges briefly, then returns to stillness. It shines not like a comet, Kaku observes, but like a mirror. Perhaps it reflects more than sunlight, perhaps it reflects meaning. The world watches in collective wonder. News feeds fill with live images, graphs, predictions. Commentators ask if this marks a new chapter in interstellar discovery. Some claim the flare awakened an electromagnetic echo, an imprint left by the object's material. Others, cautious, remind that nature often imitates mystery. Then, as the alignment begins to break, something unexpected happens. Borisov changes direction, subtly, almost imperceptibly, but real. Its new trajectory shifts a fraction of a degree off the predicted path, enough for computers to register the deviation. Analysts replay the data again and again. The movement coincides exactly with the peak of the solar flare. The Sun calls, Kaku murmurs, and the object answers. No explosion, no destruction, only a calm adjustment, as though Borisov has completed its course. In the following days, the object begins its retreat, drifting away from the Sun, back into the deep. The resonance in the solar wind fades. The storm quiets. Earth's magnetic field stabilizes. The lights in the sky dim, leaving only the steady pulse of normal starlight. In the aftermath, the world's space agencies compile every byte of data. The final report lists Borisov as a comet. Though comet feels almost inadequate, its density, composition, and behavior remain unsolved. It will not return. Its orbit extends beyond the heliopause, vanishing into interstellar darkness, carrying with it the unanswered questions of a generation. Kaku's final narration closes the story like a meditation. Sometimes discovery is not about finding answers, it is about learning how to ask better questions. We called it a comet because we had no other word. But perhaps Borisov was not an intruder at all. Perhaps it was a messenger, a reminder that our science, no matter how advanced, still stands at the shore of an infinite ocean. The camera pans outward from Earth, the continents glowing faintly under auroral residue. The sun burns in the distance, surrounded by the invisible paths of the three travelers, one golden, one blue, one silent. Slowly the image fades into the black fabric of the cosmos. Text appears on screen, glowing softly like starlight. C/2025 V1 Borisov, perihelion, November 16th. The signal ends, but the question remains. A pause. Then Michio Kaku's voice returns, calm, curious, eternal. We may never know if it was coincidence or communication, but what we do know is this: the universe is listening, and so must we. The screen fades to black. A single tone hums faintly like the echo of distant space before dissolving into silence.